Theorem of parallel axis. In this module, you will learn about the theorem of parallel axis. Consider a sphere for which you want to determine the moment of inertia about an axis. Let the chosen axis of rotation be ZOZ'. Now, can you think of a method or a tool to determine the moment of inertia of the sphere about this axis? Well, the tool you can use is the theorem of parallel axis. Let us apply the parallel axis theorem to determine the moment of inertia of a sphere along the ZOZ' axis. To do this, consider a point mass mi at a distance xi from the axis of rotation ZOZ'. From the definition of moment of inertia, the moment of inertia of mi will be mi into xi square. Now, through the center of mass C, consider an axis PCP' parallel to ZOZ'. The distance between PCP' and ZOZ' is d, and the distance between the center of mass C and the mass mi is ri. As the distance xi of the mass mi is equal to d plus ri, the moment of inertia about ZOZ' mi into xi square can be given as mi into d plus ri whole square. Let us now understand the application of the parallel axis theorem to find the moment of inertia of any object. For this, consider a disk of mass m and radius r whose moment of inertia about the center of mass is half mr square. However, the moment of inertia of the disks along the selected axis can be represented as Iz equal to Icm plus md square. Here, as d is equal to r and Icm is half mr square, the moment of inertia Iz is found to be 3/2 mr square. Thus, you can note that the theorem of parallel axis is applicable to three-dimensional as well as to two-dimensional objects along a specified axis if you know the moment of inertia of a body about a parallel axis through its center of mass and the distance of the parallel axis from the specified axis. In this module, you have learned the moment of inertia of a body about any axis is equal to the sum of the moment of inertia of the body about a parallel axis passing through its center of mass and the product of the mass of the body and the square of the distance between the two parallel axes. The theorem of the parallel axis is applicable to three-dimensional as well as two-dimensional objects at any chosen axis.